In Mac OS or your iPhone or iPad, there's a very interesting feature. It's called Private Relay. It's part of the iCloud functionalities. In this video, we will discuss how it works, how it's related to DNS service. Let me use my Mac OS to have a short demo to see the effect of private relay. Let me go to settings, iCloud, private relay. If it's not on, you can turn it on. And here for the IP address location, I choose the country and the time zone setting. Later we will explain this. This is a very important setting in your private relay. Hit done. So it's enabled. Ignore here. Apparently there's some bug in macOS. It's not refreshed. It's already enabled. Then let me launch a browser. You know, when you visit website, they can see your IP address. Some people may not like it. The private relay can hide that. So if I go to what is my IP address website, as long as I see this IP address, I know it's not really mine. And here for region, no, it's not my state. The only thing which is correct is the country. That's one of the effects of the private relay. If you want, it can hide your region. After seeing this, you may think, isn't it just VPN? No. It is not. In fact, it works totally in a different way and it has different effects as VPN. In fact, it has very close relationship with different DNS technologies. Let's start from DNS, then talk about what's DNS over HTTPS, which leads to something called Oblivious DoH. In the end, let's explore how Apple's iCloud private relay works, how it's related to Oblivious DoH. We all know how DNS works, but let's still briefly talk about it. In your operating system, for example, macOS, in the network setting, for each interface, you can configure the DNS servers. In my case, it's pointing to my router. What you are really configuring is the DNS resolver. It can accept the query from your program, for example, your browser, and then the resolver will do the query for you. It will reach out to different level of DNS servers. So basically, these two things together, you can treat them as the so-called DNS server. But of course, in your operating system, you don't set the name server. Leave them to be worried about by the resolver. So let's say your browser want to visit example.com. The root name server will point to the .com name server. Then .com name server will point to the example.com name server. In the end, as long as the recursive resolving process is done, the final IP address is returned to your program, and then your program use that IP to access your whatever internet resource. In RFC document 1035, you can find a lot of details about DNS. My diagram is just the simplified version for easier understanding. Now let's do a simple testing. Let me run command dig, which is related to DNS activities. Let me try to resolve the example.com address, and let me get the A record, which is just the mapping from domain name to IP address. Let me start capturing in Wireshark. Then run it. Okay, it's captured. Stop capturing. Let's see what's captured. First message from my machine to my router. Remember, in my macOS configuration, the router is configured as DNS. It simply asks, how do you resolve example.com? And then from my router, it returns, okay, it's with this address, and it's the same information as you can see in the terminal, right? So basically, my router will do all the legwork. Depending on my configuration, it can either reach out to my ISP's resolver or reach out to public resolver. Just from the captured message, you may already see the problem, which is my local machine's IP address and the domain name. They are both visible in clear text. The messages are not encrypted. If you really care about privacy, it may cause concerns. Let's move on, see how we can partially address the issue using DoH. DoH or DNS over HTTPS uses HTTPS to transfer name resolution request and receive responses so that it can prevent, for example, DNS spoofing or man-in-the-middle attacks. It doesn't use whatever local recursive resolver you originally had. Instead, it will use public recursive resolver. Your program will only communicate with this DoH server, the public resolver, with HTTPS. Then the resolver, of course, it can use the standard DNS to query the names. It doesn't use the local recursive resolver. It can hide the name resolution request from, let's say, your ISP, if that's what you want to achieve. Let's have a short demo on that. On my local Mac machine, I installed DNS proxy from Cloudflare. This is the package information. Let me start capturing using Wireshark. Filter on DNS. So far there's no queries. Then in the terminal, let me run dig command against my local IP address, which means I want to walk around the standard setting for DNS server in my operating system. I want to use the local DNS proxy I installed. Let me query the UI.com address. Right? Okay, it's done. I successfully got the IP address, but in the captured packages, you don't see the corresponding ones, right? Let me stop capturing because I'm using DoH, so you don't see the standard DNS messages on my Ethernet interface. Let's see whether we can find any HTTPS communications. In Wireshark, I can see TCP or TLS related frames between my local machine and 1.1.1.1. I suspect these frames, they are for the DoH operation. Let's check the configuration file for my local proxy DNS. This is the configuration file. As you can see, I configured two upstream DNS server. The first one is from Cloudflare. The second one is from Google. That's why by default, my local DNS proxy will communicate with 1.1.1.1. So basically, we found two things. First, there's no corresponding DNS frames, even though we did a name query. Second, we found the HTTPS messages between my local machine and the upstream DNS server. That's how the DoH works. But the client on my local machine has to reveal my local IP address when doing the HTTPS operations. There's no way for the DoH client to hide the local IP address. That may concern some people. Let's see how ODoH can resolve this issue. To furtherly hide the information about your computer's IP address and the domain name you want to query, in 2022, Apple and Cloudflare submitted a new RFC 9230. This is not a standard yet. It's just an experimental protocol. ODoH or Oblivious DOH. The purpose is to keep the knowledge of the query origin, which is your computer's IP address, and the query content, which is which domain name you want to access, known only to the client, your computer itself. Of course, it will improve the privacy furtherly. In the whole message path, there's no any single server entity knows both information. To finish the Oblivious DOH access, there are 3 parties in total. We need Oblivious client, your computer or your browser, and then in the middle there's a special server entity which is called Oblivious proxy. In the end, there's a Oblivious target. The Oblivious proxy is like a HTTP proxy, but it's not a full-featured HTTP proxy. It simply forwards the request to the Oblivious target. It will communicate directly with your client using HTTPS. The Oblivious proxy will communicate with the target, and the target, normally it can be a recursive resolver, and it will complete the DNS query. Let's see how the privacy protection works. When the client connects to the proxy, the client needs to decide what is the proxy it wants to use, what is the target it wants to use. Then it will connect to the proxy and provide the query. It will also need to provide the target. Then the proxy knows the query itself, will forward the query to the target. The target, yes, it knows the proxy IP address, but it doesn't know your client IP address. That's how the whole process works. But you may ask a very important question. DNS resolver does need to know your IP address information so that it can decide your geolocation to return tailored DNS query response, right? Then if you don't provide the IP address of the client, how the resolver, the Oblivious target, achieve that goal, right? Here, I note down how it works. Basically, it is something mentioned in another RFC called eDNS0 client subnet option. The Oblivious proxy convert the client IP address information into this client subnet option provided to the Oblivious target. So then the name resolving will return the tailored response without knowing the exact client IP address. If you use Firefox, Firefox supports Oblivious DoH. If you go to the configuration for Firefox, search TRR, which stands for Trusted Recursive Resolver. There's a mode setting. You need to set it to 3 to enable ODoH. And then if you search ODoH, you can find a whole bunch of settings. The most important information is here, the target and the proxy. Remember, there are 3 parties in the whole ODoH process. The client need to decide which proxy to use, which target to use. So for the Firefox case, it's configured in the browser's configuration. Okay, it's a very complicated process. Now let's look into Apple's iCloud privacy relay to see how ODoH is used there. Let's see how iCloud private relay is related to Oblivious DoH, but how it's different than Oblivious DoH. At this moment, only Safari support the iCloud private relay. That's the only client we can use at this moment. The client will reach out to the proxy server, which is similar to Oblivious DoH, but that proxy server is very specific one. It's owned by Apple. It is an ingress proxy server. It's the first relay. Here it will communicate with Apple's proxy server using a special protocol called QUIC. Apple's relay server or proxy server, of course, it will know your client's real IP address, but as noted here, your query itself is encrypted, so Apple doesn't know your query. Apple's first proxy server will connect to a second proxy server. It's an egress proxy server. This is the second relay in the whole process, owned by third party. As you can see, this is the difference between ODoH and iCloud private relay. There are 2 relays or 2 proxy servers involved. This process ensures there's no any single step except for the client itself knows both information, the original IP address and the query, the website you want to visit. There's a red dash line here. In the left side, the Apple relay server knows this information, but not the website name. But in the right side, this part knows the website name, but not the original IP address, only the relay IP address. This leads to another topic. When your client reach out to Apple Relay, a new IP address, a temporary IP address from a pool of IP addresses will be used, and let's call it relay IP address. That IP address is not your original IP address. That leads to a problem similar to ODoH. What if you do want to expand expose some type of geolocation information so that the DNS server can return tailored response, not just DNS server. Let's say if you visit Google Maps and you want to search the nearby restaurants, you don't want to give Google Maps your real IP address, but you also want to get the real nearby restaurants. How you can achieve that? If you check the iCloud private relay setting, you can see the two options about IP address. If you choose the first option, Apple will use a IP address which is not the same as your real IP address, but from the same geolocation, so that you can still have the tailored result when you visit internet. But if you choose the second one, Apple will simply use a very generic IP address which has nothing to do with your real geolocation. For example, for me, Apple will simply use a whatever US IP address. And similar to Oblivious DoH, as we mentioned previously, it will use this DNS option, eDNS0 client subnet. So in both DNS query and normal internet surfing, you hide your real IP address, but if you want, you can use the same geolocation to get similar surfing result. Okay, let's look at the whole process again. This type of architecture ensures it will separate the two types of information. First, your IP address. Second, which website you want to visit. If you have a Mac and you use Wireshark, you can easily capture the packets. If you try to use Safari browser to visit any website, the very first step, the browser will try to reach out to a nearby Apple data center. So I don't want to show you that information for my case. That's why I will not demo that, but you can do it. It's pretty straightforward. By the way, regarding the cloud private relay, there are very limited information or documentations on the web. For the existing very few websites, sometimes they have confusing or even contradicting information. So this diagram is I prepared based on what I understand. If you see anything wrong or if you have any comments, please let me know in the comment area. Okay, thanks for watching.